already expanded binomial, and you can use the already expanded binomial to expand an expression to an approximate value or to evaluate it. Example, I can be asked to, let's say, expand this. Let's look at another lesson on binomial theorem. I think this will be our lesson 5 on binomial theorem. Okay, and we are going to look at approximating of an expression using binomial expansion. So here we can be given an expression to expand using, say, 5y exponent 8. I should expand this. Okay, and after that I can be asked to use my expansion. Use your expansion to evaluate maybe 1.25 exponent 8. All right, so you are using this expansion here, already expanded binomial, all right, to solve for this particular question. Use the expansion to evaluate this to an approximate value. So something like this, what we do is to compare. All right, to compare. So we have 1 plus 5y exponent 8. So after you have expanded it, this is 1.25. So you can write this one as a 1 plus 0.25. You see that exponent 8. So that when you compare, this is 1, and then the 5y will also correspond to what? 0.25. So that I can say the 5y is equal to 0.25. Then you solve for the value of y. So after you solve for the value of y, you substitute the y into the already expanded binomial and solve. So what we do is that here is that you will already be given a binomial to expand, and then you'll be asked to evaluate an expression to an approximate value using the already expanded binomial. So that is what we are going to do. We will compare, and then after that we will solve about 2 or 3 examples, and I will give you 1 or 2 to also try on your own. All right, so let's go. Use the expansion of 1 minus 2s exponent 6 to find the value of 0.96 exponent 6. So we are going to first of all solve this, and after we solve this, we compare with this, and then we use the expansion of this binomial to find the approximate value of this one too. So let's go. So we are going to expand 1 minus 2x exponent 6. Okay, so I hope you have not forgotten our binomial expansion. Now we can go by y1 exponent 6 in our first term. If you like, you can go by the combination method, the factorial method. Then we have 6 here. All right, multiply 1 exponent 5. Okay. Then we have negative 2x exponent what? Exponent 1. Okay. So you see, so in some of those who are familiar with binomial, you realize that because the first term in the binomial here is 1, normally, even in our expansion, after the first term, we don't even write the 1 again. The reason being that 1 to the exponent of any number as we do our expansion will be the same as what? The 1. So we don't even worry ourselves to write the 1 again. But you can also decide to write, it won't change anything. So let's go to our next expansion. We have what? 6 times 5 over 2 factorial. Then we have 1 exponent what? 4. Negative 2s exponent 2 plus 6 times 5 times 4 over 3 factorial. 1 exponent what? 3. Negative 2s exponent 3 plus, and let's go on, 6 times 5 times 4 times 3 over what? 4 factorial 1 exponent what? 2, negative 2s exponent, it was 4, plus 6 times 5 times 4 times 3 times 2 over 5 factorial, 1 exponent 1, negative 2x exponent what? 5, plus 6 times 5 times 4 times 3 times 2 times 1 over 6 factorial will be the same as. So we have our last term as negative 2x exponent 6. Alright, negative 2x exponent 6. So let's now go use our calculator and then we evaluate everything. So 1 exponent 6 is 1. So 6 times, this one will be 1. So 6 times negative 2 will give me negative what? Negative 12x. Alright. So 6 times this will be 1. So 6 times negative 2. Then we will have 6 times 5 divided by 2 times negative 2 square, which will be 4. Negative 2 times negative 2. So plus, that will give us 60 s square. Alright. Then this one will give us minus. So minus, because the negative, the exponent is odd. So that will be 6 times 5 times 4 over 3 factorial. 3 factorial. So that is 3 times 2 times 1. Okay. Then negative 2 times negative 2 exponent 3. That will give us negative 160 x cubed. Then you'll be positive because with the negative, the exponent is even. So that will be 6 times 5 times 4 times 3 over what? 4 factorial. That is 4 times 3 times 3 times 1 times this one will still be the same thing, negative 2 exponent 4. That will be plus 240 x exponent 4. Then minus, because of the odd exponent of the negative, times 2, 6 times 5 times 2 divided by 5 factorial, 5 times 4 times 3 times 2, also multiply by negative 5 exponent, negative 2 exponent 5, that will be minus 192 x exponent 5. So then finally plus, we have negative 2 exponent 6. That will give us 64 x exponent 6. 64x exponent 6. So this is what we have for our binomial expansion of 1 minus 2s all to the exponent of 6. This is the binomial expansion. And we are going to use this expansion 1 minus 12s plus 60s squared minus 160s cubed plus 240s exponent 4 minus 190s exponent 5 plus 64s exponent 6 to expand 0.96 or exponent 6. Okay, so we are going to compare to this. This is 1 minus 2s exponent 6. So that we rewrite it as this and substitute the value of s and so. So what we do here is 1 minus. So 1 minus what value will give me 0.96. So that we can compare to this. So 1 minus what value will give me 0. So here's 1 minus 0.96. That will give you 0.04. So it means that 1 minus 0.04 will give me the same as 0.96 exponent 6. So 0.96 is the same as 1 minus 0.04. So 1 minus this will give you the value as the same as this. So 1 minus 0.96 will give you 0.04. So 1 minus 0.04 is the same as 0.96 exponent 6. So here is 1 and then minus is here. So the 2x is the same as 0.04. So it implies that our 2x will be equal to, so the 1 is the same, the negative is there, so the 2s is the same as, will be equal to 0.04. Then let's find the value of the x. So what to be the value of the x? So my x is going to be 0.04 divided by 2. What I'm doing that, so that I will use this to expand. So the value that I'll get for x, I'll substitute here and then use this expansion to solve, so that anywhere I see x, I'll substitute the value of x. So 0.04 divided by 2 will give me 0.02. So our x is 0.02. Okay, then we can write it as what? Our 0.96 exponent 6 will be equal to 1 minus 12. What is the s? Times 0.02 plus 60 times 0.02 squared minus 160 times 0.02 cubed plus 240 times of 0.02 exponent 4 minus 192 0.02 exponent 5 plus 64 0.02 exponent 6. So this is what we have, and with this, what we are going to do, we are going to put it on a calculator and see the answer we are going to get. Okay, so minus 12 times 0.02 will give us 0.24. Then 60 times 0.02 squared will give us plus 0.024. Then minus 160. I think it's 160, right? 160 times 0.02 cubed. That will be 0.00128. Okay, that is this one. And then 240 times 0.02 exponent 4 will give us plus 0. How many zeros? 0, 0, 0, 0, 4 zeros, 384 minus. So as we are moving, the value will be getting closer to 0. So minus 192 also to the exponent of what? 5. Oh, that is 0.123456 6144. I can't imagine how the last one is going to be. 64 times 0.2 exponent. So 8 zeros. 0.1, 2, 3, 4, 5, 6, 7, 8. 4, 1. So we have 8 zeros. 4, 1. Okay. It's funny how we are getting. Then we are going to add 1 minus 0.24. We are going to put everything plus 0.024 minus 0.1200128 plus 1234 0.1234 zeros 384 minus 1 2 3 4 5 6 zeros 0.123456 606144 plus how many zeros? 1 2 3 4 5 6 7 8. 0.1, 2, 3, 4, 5, 6, 7, 8, 4, 1. So at the end of the day, we are getting, so adding everything, our answer, we have put all together. Let's see the answer we are getting now. We are getting 0.782757. Okay, so 58 is okay. So 0.96 exponent 6 is 0.782758. After that, we can put this on the calculator and confirm if our answer is correct. So let me put it on the calculator. 0.96 exponent 6. Yes, it's also 0.78275778. Okay, so it means our answer is 100% correct when you put it on the calculator. So we have used this expansion of this binomial to evaluate this particular expression here. All right. So let's try one more question, and then I'll give you one to also try on your own. Write down the first 4 terms of the expansion of 2 plus s on 4 exponent 10 in ascending powers of s, and use your expansion to find the value 2.025 exponent 5. So we are writing the first, just the first 4 terms. This is exponent 10, so exponent 10 will reach up to 11 terms. We are just writing the first 4 terms in ascending powers of s. Ascending powers of s means that as you will be moving on, the exponent of the s will be increasing because x is in the second term. So x will start from the second term in our expansion, and then to increase like that. So let's go on. So our first term is 2 exponent 10 plus 10 will multiply 2 exponent 9. Then s over 4 will come, plus you will have for 10 multiplied by 9 over 2 factorial, then 2 exponent 8, then x on 4 exponent 2. So 1, 2, 3. It's left the last one according to the instruction of the question. So 10 times 9 times 8 over 3 factorial, 2 exponent what? 7. S on 4 exponent 3, and so on. Okay, so let's move the calculator, and then we'll do our expansion, and we'll see what we are going to get. So 2 exponent 10 will give us 10 to 4 plus 10 times 2 exponent 9 times, this is 1 over 4 because the coefficient of s is 1. So times 1 over 4. That will give us 1280x plus 10 times 9 over 2 factorial times 2 exponent 8 times 1 over 4 exponent 2. That will give us 720 s squared plus 10 times 9 times 8 over 3 factorial times 2 exponent 7 times 1 over 4 exponent 3. That will give us 240 s exponent 3. Okay, so 1, 2, 3, 4. We have our first 4 terms, and we are going to use to evaluate what? 2.025 exponent 5. So 2.02, when we compare, it means here should be 2 plus 2 plus what value will give me 2.025? That is 0.025 exponent 5. So if when you subtract 2.025 minus 2, it will give you this. It's that when you add 2 to this, you get this. So we are going to find, when you compare 2 is here, it means that x over 4 is the same as 0.025. So my x over 4 is equal to 0.025. And my x will be 4 times 0.025. That will give me 0.1. It means that the value of x here is 0.1. All right, 0.1. Then I can now say 2.025 exponent 10. Okay, so the original here should be exponent 10. The exponent should be the same. All right. So we are going to use to evaluate exponent 10. So exponent 10 is equal to 10 to 4 plus 1280 multiplied by the s, which is 0.1. So we substitute s into the expansion. Then 720 divided by 0.1 exponent 2 plus 240, 0.1 exponent 3. All right. So that we have 10 to 4 plus 1280 times 0.1 will give us what? 128 plus 720 times 0.1 square will give us 7.2 plus 240 times 0.1 key will give us 0.24. So when we add everything, we have 10 to 4 plus 128 plus 7.2 plus 0.24, and that will give us 1159.44. So this is our final answer. So we are going to confirm if it is correct. So 2.025 exponent 10, 1159.44 exactly. So our answer is correct, 1159.44. So I believe that you have gotten the understanding. I'll come your way with another lesson on more questions on this. Okay, this is so simple. Just compare them, find the value of s, and substitute into the expansion of the s, and you are good to go. I hope you enjoyed it. Make sure to subscribe, share, and comment. See you once again. Bye bye.